today's lesson is going to be part 2 of Learning Target 2, where we're trying to be able to solve equations using addition, subtraction, multiplication, division. But here sometimes you get equations that involve fractions. And so this part of the video, I'm going to try to show you different ways of dealing with them. And I'm going to show you different ways. So I would like you to pick the way that works best for you, and then go with that. Okay. So example 1, we have 2/3 x equals 7. Okay. So for this one, I'm going to show you using the reciprocal. So I kind of talked about that in the last video when you have division. So that's the reason why you just multiply. But you usually don't write it like that, and so that's okay. But with a fraction, it makes sense to write it like using a reciprocal because it's written like to the side, so x is not in the fraction at all. So the reciprocal of 2/3 look like that would be 3/2. So it's really just the flip of the fraction. So the denominator becomes the numerator becomes the denominator. Okay, and so if it's 2/3 is reciprocal of 3/2, then that's what I'm going to multiply to both sides. Okay, now notice the 7 on the right side is not a fraction, and that's okay. So to be able to multiply across, I would make 7 a fraction because any number is really a fraction. It's just that we don't like writing over 1 for them because it's kind of redundant and everything's divided by 1. So I don't really need it until I want to use it. So now is a good time to use it. So I put it over 1 and then I multiply across for both of them. So 3 times 2 is 6 divided by 2 times 3, which is 6. And on the right side, 7 times 3 is 21. 1 times 2 is 2. Now 6 divided by 6 on the left gets me 1, so I'm left with x, which is what I want. Now you can either choose to leave this as 21/2, which is fine by me, or you could make this 10 1/2 if you wanted to, or you could make this 10.5. Any of those answers are perfectly fine. I would just like you to pick one unless something else is specified to be used, but all three of those are fine. Okay. Here with an example 2, you have -1/4 plus c equals 2. One way of dealing with this is something called clearing the fractions. And so what you're doing is you're looking at all your problems, or all the terms in your problem, and you're trying to determine what the common denominator of everything is. And whatever the common denominator is what you multiply to each and every term in the equation. Okay? So looking at this, I have -1/4, so it looks like that's my denominator 4. C and 2 don't have denominators written, but they do have denominators because they can be written as fractions. So they are 1. So remember, common denominator or least common denominator is the smallest number that they are all multiples of, or can be like made into. So 1 can be made into any number. So then we can make them all 4. Now you don't always have to use the least common denominator, but it usually makes everything easier when you do. It leaves you with less things to reduce at the end. So now, like I said before, I'm going to multiply everything by 4. Okay, so that means -1/4 times 4, and so over 1 gets me -4/4, then plus 4c. Now here, because I didn't really need the over 1 to begin with, like at the beginning, you don't have to make these into fractions to do this. So I can just say it's 4c, and 2 times 4 gives me 8. The over 1 just helped me figure out what the common denominator of everything was. Okay, so now going to be -1. And so then now, notice I have no fractions. And now I can solve it with utmost ease here. So I can add 1 to both sides. It gets me 4c equals 9, and then divide by 4 to both sides to get me 9/4. You could say 2 1/4. You could say 2.25. All those are perfectly fine answers. Just make sure you're picking one that makes sense to you. Okay. And also notice that was like a 2-step problem at the beginning. Or 3 steps actually. So I cleared the fractions, that's 1. I added both sides by 1 to move that over, and then I divide by 4. That's a little bit more of an advanced skill for that one. But I figured I want to show you to you now before we get to ones where it actually will come in handy. But you can still use it now to kind of help you out. So, like, for example 3, if it was just a division with a fraction, so both sides are fractions, like in example 3 and 4, I could multiply everything by a common fraction, so, or the common denominator. So for 36 and 9, I could go and make them both 36, right? So I can multiply everything by 36. So I'm putting them over 1 because everything's over 1. So it gets me 36a over 36. And then here, 4 times 36 would be 144 over 9, which 36 divided by 36 is a, or 1a. 144 divided by 9 is 16. Remember, for those bigger numbers, make sure you're using your calculator. Very helpful when you're doing that stuff. Okay? And now another one, and I can show you this too, but I'm sure you're going to know how to do this one. Anytime you have two fractions that are equal to each other, you can use cross multiplication, and that works. So here I can multiply negative w and 5 and negative 2 and 45. So that gets me negative 2 times 45, 5 times negative w. So it gets me negative 90 equals negative 5w. And then it comes a one-step problem after that. So dividing both sides by negative 5. So negative 90 divided by negative 5. Remember, that's going to be positive. And that'll be positive 18 equals w. And that's my answer. Okay? And then from there, now we've kind of want to start combining our two thoughts that we've had. So in the first learning target, we were writing equations or sentences into equations and vice versa. And then at the beginning of this one, we were starting to solve equations. Now we want to combine or marry both those thoughts into kind of the same problem. So I'm going to give you something in sentence form, and you will need to convert it into an equation. And then from there, you need to solve. So like example 1, it says 2/3 equals negative 8 times a number. So let's go through this. So there's 2/3. There's an equal sign. I see a negative 8. And then times a number. So it says to use x. for when you see a number. So then my simplified version of my equation would be 2/3 equals negative x, or 8x. So then this becomes just another problem where it looks like negative 8 is multiplied to x. Now this one's a little bit tricky because you have a fraction on the other side of your equation. So that means that dividing both sides by a number is not as easy as it looks. So one thing you can do is using our reciprocal idea that we talked about before, which is very useful here. So reciprocal for negative 8 would be negative 1/8. So you keep the sign, but you're flipping the fraction because it's like negative 8 over 1. You flip the top to the bottom and the bottom to the top, so that now I get that on both sides. So that gets me negative 1 times 2, which is negative 2. 8 times 3 is 24. Then over here, negative 1 times negative 8 gets you a positive 8. X, it looks like. And then 8 times 1 is 8. So then now reduce. So negative 2 divided by 24 is negative 1/12. Because they both have a 2 in common. So I can reduce them. And then 8x divided by 8 leaves me with 8. Because 8 divided by 8 is 1. And so that's my answer. Now you can make negative 1/12 a fraction, or decimal I mean, but it's really easier just to leave it as the fraction. Okay, next one. So example 2 says 5/11 times a number is 55. So 5/11 would be 5 over or divided by 11. And then times a number is, which would be your equal sign, and 55 is just like it sounds. So putting that together, there's my equation. So then now, this one's a great one to be able to use through reciprocal on. Or how about this? If I have just one number on the bottom, you can kind of separate them into two different problems. So you're being divided by 11, right? So division means that I need to multiply. So if you just multiply both sides by 11, that would make this a little easier. So that gets you 55 over 11 times x equals 605. Pretty big number for 55 times 11. And 55 over 11 gets you 5x. Okay, one more step. 5x equals 605. 5 is timesing x, so you undo that using division. So now x will equal 121, because 605 divided by 5 is 121. That's my answer. Okay? So then the last example for this, now it's going to be a little bit more of a word problem. So you kind of have to look a little deeper to figure out how to write your equation. So here it says a certain movie made $1.6 million in sales. Its sequel made $0.8 million in sales. How much more did the first movie make than the second, or the sequel? Second movie, same thing. So here I want to use the words that are given to me. So it looks like how much more. So they told me what the first movie made, right? So, or I guess it told me that, or what both of them made. I want to kind of know what the difference between the two are. And that's a key right there, difference between the two. So, and they also use the word more than. So hopefully you've seen that phrase before when we're using addition. So there should be some type of addition here. So here, one way of writing this would be, well, if you know that the first movie is more than, now we're not going to use any inequalities, but you can write 1.6, and that will equal whatever is missing plus the amount of the second movie or the sequel. Solve it that way. Or, because I kind of used the word difference there, the difference between the two is the actual amount that the first one made or over the sequel. So you could say 1.6 minus 0.8, which equals x. That one's a little simpler. Either way, they're both equations essentially. One is just easier than the other. So then now on the left side, you could say 0.8 subtracted to both sides. So 1.6 minus 0.8 would be 0.8. Or on the other side, that's the same idea. That's the same as this. So you're basically doing the same thing. Just one's a little quicker. Okay, so either way, you're able to state that the first movie made $0.8 million more than the sequel, or than its sequel. Okay, and always for word problems, you don't just, it's not just simply writing the answer, it's writing it in a sentence that makes sense. Okay, and that's it. Have fun.